Welcome to David Alexander Maths Tuition. This is chapter 13a, integrating x to the power of n. Okay, so integration, we need to remember, is the opposite of differentiation. So this is how we do it. We increase the power by 1 and then divide by that new power. So 2x cubed becomes 2x to the 4 divided by 4, and 2 over 4 is 1/2. So we can write that as 1/2 x to the 4. Okay, so let's just check by differentiating that this integral is correct, and let's see if we can take it back to 2x cubed. 1/2 times 4 is 2, and drop the power by 1, x to the power of 3. Now, when we integrate, we always put in a plus c afterwards. This is the constant of integration. Okay, so let's say, for example, I was differentiating 4x squared plus 9. Well, that would simply become 2x, and the 9 vanishes. Now, if I were to differentiate 4x squared plus 10, it's exactly the same derivative, it's just 2x. So when we're integrating, well, how do we know that 2x is going to integrate to 4x squared? Or, in fact, 4x squared will just differentiate also to 2x. So how do we know that when we're integrating 2x, we're not going to 4x squared, or 4x squared plus 9, or 4x squared plus 10? We don't know what's going on here, so that's why we put on the plus c. Very easy to miss that bit off as well. Okay, let's look at another example. So we're going to increase the power by 1, so minus 2 plus 1 is minus 1, and then we're going to divide by that new power, minus 1. So we can write that as negative 7x to the negative 1. With a bit of practice, you'll be really fast on these. The only problem is, once you start doing integration really well at the beginning, that will confuse your differentiation, and vice versa. Your differentiation will confuse your integration depending on which topic you visited the most recently. So we're going to increase the power by 1. 1 is 4/4. 3/4 plus 4/4 is 7/4. And we are going to divide by 7/4, which is the same as multiplying by 4/7. So that is going to be 24 over 7, x to the power of 7 over 4 plus c. Okay, 4x to the 5 becomes 4x to the 6 over 6 plus 3x cubed over 3. So this number 7, that is 7x. We can write 7 as 7, well, we're not going to write it, but 7x to the 0, increase the power by 1, divide by the new power. So that just becomes 7x plus c. Okay, and 4/6, that can be 2/3 x to the 6. 3 over 3 is just 1, so that's plus 1x cubed plus 7x plus c. Okay, find y given that dy by dx is this stuff here. Okay, so dy by dx means that is the derivative. So something has been differentiated and we've got this. If I differentiate a y equals some stuff, then if I differentiate it, I get dy by dx equals some other stuff. So what I need to do here to go back to the original thing is integrate. So what I'm going to do with this one is I'm just going to expand the brackets, so 3x plus 5 squared. When you do year 13, there is a quicker way of doing this. So that's going to be 9x squared plus 15 plus another 15x, that is plus 30x plus 25. So that's going to be 9x to the 3 over 3 plus 30x squared over 2 plus 25x plus c. In other words, 3x cubed plus 15x squared plus 25x plus c. Okay, let's look at the next one. So this is similar. Find the function of x given that f dash x is 4x to the half. Or remember that f dash x is another way of writing our derivative. So we want to integrate this. So I'm going to increase the power by 1 and divide by the new power. So I'm going to divide by 3 over 2, which is the same as multiplying by 2 over 3. So that is going to be 8/3 x to the 3 over 2 plus the c.